system. So in this episode, I'm going to talk about the following things. We're going to briefly review what other unit systems exist and what are the common unit systems that we used in this book. The second part is we also going to give you the idea about the fundamental units. Some of the units are the most basic units. Some units are actually a derivative units, which is composed by the fundamental units. And one of the major calculation that you will see over and over again is the unit conversion. So we are going to briefly discuss about the unit conversion. And this is very important, and in your homework, you're going to do some practice about this. So make sure that you understand how to do a unit conversion. The last thing, I'll just briefly talk about the dimensional analysis, which is very fundamental idea, and this is also based on the unit conversion as well. Okay, so a quick review. If you already see the pre-lecture, so you should have an idea about these things, and I kind of summarize all this idea together. Okay, unit. Unit is important because a quantity without units are useless. It doesn't mean anything. And there are many units used in the physics. Some are fundamental, some are derived units from the fundamental. So let's talk about the unit system first. Basically, there are two big categories. One category is actually the international. And the other is the US. So we are very different from most of the world, and the majority of the world use what we call the international unit system. In the States, our unit system is a little bit different. So what is the international unit system? The international unit system basically has two subcategories. One is what we call the SI unit. And the other one is what we call the CGS. The SI unit is also known as the MKS unit system. Let me show you why we call this. Well, basically, this is based on the idea of the fundamental units. Fundamental units. You can see the fundamental units. We list several of them. We list time, the length, and the mass. Which means if you have a unit, most likely it's going to be a unit which is a fundamental, or it could be a combination of these units to compose a new derived units. So if you think about, for example, volume, what is the unit of volume? The volume usually has to relate to the length, but it's not only just the length. If you use one length times another length, like the width times the height, it's going to give you an area. But area is not volume. So how do you get volume? You have to multiply another length. So a volume is simply a derived unit from the length, and you're going to have several of them. So these three are the most common fundamental units that we are going to use in the first part of physics. If you go to the next part, we also have some other kind of unit system. Oh, there's another one that we will use as well, which is temperature. You could also have current, and that's the second part of the physics, and that is also a fundamental units. More for example, is another like fundamental units, but we don't use more a lot in this class. So we're going to focus on the first three things. And if you look at international unit system, time, when we use time, we use second. So this S over here simply represents the second. If you talk about the length in the SI unit system, and length represent meter. So this N simply represents the meter. What about a K? Well, K related to the mass, and that is when you talk about the mass is in the kilogram. Or simply just write kg. That's how we get the SI unit system coming from. Sometimes SI unit system, the unit is quite large. If you have a very small change or very small value, you will get a very, very small value if you use the SI unit system. So if you have a small value to represent the quantity, we probably will use another unit system, which is what we call a CGS. And the CGS represent centimeter. This represent grains. This represent the second. So instead of using a meter, we use centimeter. Instead of using kilogram, we use grain. And time is always going to be in second. Well, the US system is different, but we don't have like a very special name for that. And we just say this is a US system. For the length, you know, we use a feet or inch, right? If we're talking about the mass, and we're not using the kilogram or gram, we use pound. Well, pound is a very weird unit system. Sometimes pound represent pound mass. Sometimes pound represent pound force. We will discuss about the difference between the mass and the force later, but you have to remember sometimes when you just simply say pound, it could represent mass, it could represent force. So it's a kind of a confusion. Time in the US system is also used the second. So this is the length, this is the mass, this is the time. Okay, once you understand the unit system over here, in our book, we will most likely going to use this, but sometimes we will give you the US system and you have to know how to change this one into the SI unit system. So it's important to know how to do a unit conversion. And the rule of doing a unit conversion is very simple. When you do a unit conversion, you simply multiply the ratio of the equal units. Okay, what does that mean? What is the unit? What does the equal units means? The equal units means, even though we have two different unit systems, but we can find what is the value that will make these two unit systems to represent the same thing, which means they are equal. Okay, for example, if you look, sometimes if we give you an exam, we are going to give you a table of the units so you can do the unit conversion. So 1 feet, if you look at the table, it will tell you 1 feet is equal to 0.3048 meter. Okay, so that means if you have 1 feet, that's equivalent to this amount of the meter. If you have a number of the feet and you want to convert into the meter, then what do? Say, for example, I have 3.5 feet in length. I wanted to find out, can you tell me how much meter that is? And we want to find the answer of this. And to do that, you use the idea of a unit conversion. And remember, you simply multiply the ratio of the equal units. What is the equal units? The equal units is this one here. The ratio of that represents this. It can be the 1 feet on the top or the 1 feet at the bottom, because they are all equal. So you can put anything on the top or the bottom, and depends on your needs. Okay, and when you do the conversion, you multiply this equal units and try to get the answer. So let me make a little bit of room over here. And the goal I want is to convert this one into this one here. So I multiply the ratio of equal units, either this one or this one. So which one should I multiply? The answer is the later one. And the reason is once you multiply this, you can see this phi over here will be canceled out because one is numerator, one is the denominator, and they are one on the top, one at the bottom. Then you can cancel them out, and what you have left is the meter on the top, and that's exactly what we want. I don't have a number for this, but you can do your multiplication by yourself. Just be careful about this. When you do a lab, we're also going to talk about the significant figures. When you have two numbers with a different number of the digits, then you have to consider how many digits that you should keep. We don't keep all the digits, and there's a rule. So pay attention to that. I'll let you figure it out after you learn this in the lab. Okay, so let's talk about the dimensional analysis. Well, the dimensional analysis meaning if you have an equation, and we have a lot of different kind of equation. For example, one of the equation is this, that you will see this one in your textbook as well. And the first part of the chapter also tells you equation is kind of a language that we use in the physics. We try to simplify things in some symbols to represent the relationship between different properties. So in this equation over here, you can see this equation pretty soon in the chapter 2, which will represent what is the distance of an object if the object is just moving with a change of the speed. Okay, so h represents a distance. This a over here represents a property called acceleration. The t at here represents time. Okay, you don't need to worry about this too much right now because we're going to see this equation later. But what I want to tell you is if this is what we call the acceleration, and this is what we call the time, and we use this equation to represent something on the left, where the left is a distance. What is the unit of the distance? Well, the unit of the distance is like the length. So for this one here, your unit for this one is the length. And dimensional analysis tells you if you have an equation which is valid, then the unit on the left is going to be equal to the unit on the right, meaning if you multiply the unit of the acceleration, and you multiply with the unit of the time squared, that is going to be the unit the same as the length. Okay, with this you can actually know what is the unit for the acceleration. If you don't know what acceleration is, but you wanted to know what the unit of the acceleration is, you can use this one to figure it out. And simply just make the right hand side the time square to be divided by the time square. So I can do this. On the both sides of the equation, I simply divide by time square and time square. Okay, so that means this will cancel out, and you will see on the right hand side you have acceleration, on the left hand side it give you what is equal to the acceleration. So what is the unit of the acceleration? It's equal to the length. So for example, meter over time square. What is the unit of time? The second. So the meter over second square is the unit of the acceleration. So this is what we mean by the unit analysis.